Tech in 5.
Ever wondered how top tech companies evaluate coding skills in interviews? Mastering coding challenges is your key to securing that dream tech job. Ever found yourself captivated by the bouncing DVD logo, eagerly anticipating if it'll ever hit the corner? Today, we're diving into that very question in our coding interview challenge. Now let's tackle the fun problem. Will the bouncing DVD logo ever hit the corner of the screen? You'll write a function to predict this based on the screen's dimensions, the logo's size, its starting position, and its velocity. Feel free to pause the video now and think about your approach to this problem. Once you're ready, we'll discuss the possible solutions and how to implement them. The first approach to solving our DVD logo challenge is through iterative simulation. In this method, we simulate the movement of the logo step by step. First, we normalize the speed of the logo to ensure our simulation is efficient. We divide the x and y components of the speed by their greatest common divisor to streamline our simulation. This reduces redundant calculations while preserving the logo's trajectory. We introduce boundary x and boundary y to represent the right and bottom boundaries of the screen, respectively. We then use a while loop to simulate the logo's movement. We check if the logo's current position is at one of the screen's corners. If it is, the function returns true, indicating the logo will hit a corner. After checking for a corner, we add the current state to the check position set. This is important because by tracking each unique position and direction in a set, one can prevent infinite loops in case the logo never reaches a corner. The condition of the loop will check if the current state has been encountered before. If it has, we've detected a repeating pattern, and the function returns false, indicating the logo will never hit a corner. Finally, we update the logo's position and direction at each step to simulate the logo moving. If the logo hits a wall, we reverse the relevant component of its speed, simulating a bounce. This approach methodically checks each step of the logo's journey. Transitioning from our first approach, let's explore a different method, pattern recognition. This approach changes how we predict the DVD logo's corner hit, focusing on the periodic nature of its movement. In the function, we still start by normalizing the speed to ensure our prediction is efficient. But instead of checking every possible position, we utilize the concept of periodic patterns in the logo's movement. The key here is the least common multiple, LCM. We calculate the LCM for both x and y axes, using the screen's boundaries and the normalized speed. This LCM represents the period after which the logo's movement pattern will repeat itself. Now, we simulate the logo's movement only within this period. If the logo doesn't hit a corner within this time frame, it's guaranteed not to do so in the future due to the repetitive nature of its trajectory. This method significantly reduces the number of iterations needed, especially for large screens or slow-moving logos. It's a more mathematically elegant solution, leveraging the predictability of the logo's path, compared to the brute force nature of the first iterative approach. Building on our understanding of the logo's repeated pattern, let's now unfold its trajectory into a straight line, which will allow us to precisely determine if and when our logo will hit a corner. In the image, we see the DVD logo bouncing trails. Each segment of the line within the rectangle represents the logo's trajectory between bounces. Instead of reflecting off the walls, imagine the screen extending in all directions, with the logo moving in a straight line across this extended grid. The key here is that the motion of the logo remains consistent and linear. It's the unfolding that turns the bounces into a diagonal line. This straight line can now be extended indefinitely, and we can analyze it mathematically to determine if it will pass through a corner of any of these imaginary extended screens. If the line does intersect with a corner, it means that in the real, bounded screen, the logo would eventually hit that corner. Now, let's take a look at the code. The function first consider the absolute values of speed x and speed y because the logo's movement is symmetrical across all quadrants. The function then enters a loop that will iterate enough times to cover the distance. Within the loop, y values represents the potential y coordinates where the logo could be after extending its movement vertically upwards and downwards. For each y value, the corresponding x coordinate is calculated. The formula takes into account the proportionality between the x and y movements based on their speeds. It calculates where the x-coordinate would be if the logo traveled from its starting y-coordinate to the current y value at the given speeds. If the calculated x-coordinate is either left edge or right edge, the logo is at a horizontal boundary. A corner hit is confirmed. This function provides a mathematically weighted check for a corner collision, as a most elegant solution. Got a different solution? Feel free to share your ideas in the comments.
Stay tuned for more videos on Tech in 5.